Dotted decimal, sir.
In dotted decimal, very good. Length of IPv4 address is 32 bits.
Yes, sir.
And how many field we have in IPv4?
4 fields, sir.
2 field.
4 field.
4 fields, sir.
4
4
fields.
fields.
4 field.
And we separate each field by dot.
Dots.
Right?
Dots, sir.
And
Yes.
in one field value can be from 0 to 255.
255.
Right? So that means one IP address is 10.10.11.12. This one is a IPv4 address.
Yes.
Yes.
Yes, sir.
After that, if I will talk about the classification of IPv4 address. So we have some class. How many classes we have?
4 class.
Five classes, sir. But
Okay.
we use only
We use
3
4
classes.
3 classes. Class A, Class B and
Class
Class
B,
C.
Class C.
What is the range of Class C A?
1
0
to
to
127. 0 to 127.
0 to 127. What is the range of Class B?
128 to 191.
191.
And what is the range of Class C?
191 to 222. 222.
192 to
223.
223. Very good. Right? How many network we can design from Class A? 2 to the power
1.
7.
2 to 7.
How many network we can design from Class B?
2 to the power of 14.
14. And how many
14.
network I can design from Class C?
2 to the
2 to
power
the power
of
of 21.
32.
21. Because 1 bit is reserved for Class A, 2 bits is reserved for Class B, and 3 bits is reserved for
3
Class
for Class
C.
C.
Right? After that, we have some range of private and public as well. Okay. Now I am going to write one IP address over here, that is 192.168.10.130/25. So can anyone tell me what is the network ID of this IP address? This is a valid IP address.
Class B.
Yeah, definitely this IP address belongs.
192.168.
Yes.
192.168.10.128.
Yeah, very good. Network ID will be 192.168.10.128. Is it clear to everyone? This is a network
Yes.
ID
2 reserves, huh?
and this one is valid host. In the same way, if I will ask you one more question, 192.168.10.130, but this time slash value is /26. So now can you tell me what will be the network ID?
127.
Huh?
192.168.10.128 itself.
128 itself. If /27 is there, then
Same 120.
also 120. If it is 28,
Then also 128, sir.
then also 128. So hope now this is clear to everyone that how to calculate the network ID from a valid host IP address. If you have slash value only, see, if you have IP address, first of all you should identify that this IP address belongs to which class?
Class B.
Class C.
Class C.
Once you will identify the class, you can understand the default CIDR value. And after that, you can see the given CIDR value. You can subtract the given CIDR value from the default CIDR value. You can get the how many bits you have borrowed. You can calculate the number of network. You can calculate the valid host. So if you have only slash value, let's say /27, and I am asking you how many network I can design. So you can answer it, yes or no, because here IP address is not required. But here you have to mention that IP address belongs to which class? Class A, Class B, Class C. Yes or no? Directly if I am asking that /27 and how many network I can design.
Class C.
It is from class C, sir.
How?
Because default CIDR.
It can be .10.10.10.10/27 also, na?
We can do it, sir. It can be class A, class B, class C.
Yes, it can be class A, class B, class C.
Okay, right, sir.
It can be any class. So here we cannot find the number of network until and unless you will not have information about the class. In the same way, you cannot find the valid host. Can you find valid host? Yes, I can find valid host, brother. We can find the only valid host with slash value. Yes or no? How many valid hosts are there? How many valid hosts are there?
Three.
3. No. Formula to calculate valid host is 2 to the power h minus 2. H is host bit. Total number of
5.
network bits is 27. So h is 5. 2 to the power 5
30, sir.
minus 2, that will be 30. Yes or no? So if you have only slash value, you can calculate total number of valid host IP address only. You cannot calculate the number of network. You cannot calculate the number of network until and unless you don't have information about the class. Okay. Now our next topic is OSI model. So before starting OSI model, I am going to ask you one very simple question, that is why we come up with OSI model. Can anyone explain why we come up with OSI model? What is the need of OSI model? What is the problem that OSI model have solved, or how communication was happening before OSI model? What was the problem in that communication?
Previously, each OEM has own communication protocol.
Yes.
To equalize them and to come together with the same platform, OSI model was developed.
Very good, Deepak. Deepak is absolutely right. Before OSI model, different vendor devices was actually not able to communicate with each other. Only same vendor devices was able to communicate. Like suppose I have two computers of Dell. Both computer belongs to Dell, so they can communicate. But if I have a computer of Dell and I have one computer of HP, so these two computers cannot communicate with each other. Am I right, Deepak?
Yes, sir.
Because the protocol and the process and the method of making communication is different of Dell and HP. Dell have their own algorithm for the communication and HP have their own algorithm. So that's why we come up with OSI model with a common process, with a common protocol. Like if I will give you a simple example, let's say I have one computer over here, computer A and computer B. A and computer B. Computer A want to send some data to computer B. Let's say data is how are you. This is your actual data. Actual information is how are you. Computer A need to send this data to computer B. Before sending the data, computer B will encrypt the data so that no one can read your actual data on the link. So let's say this computer A have encrypted this data into some encrypted format. Let's say it is 1 2 3 and XYZ and ABC. Let's say this one is the encrypted data of how are you. Getting my point? So definitely this machine have used any algorithm for the encryption, like H is encrypted with 1, O is encrypted with W, like that. Yes or no? So if this machine, receiver machine, know about that algorithm of encryption, then only this machine can decrypt the data when this machine will receive the actual data. See, computer B will receive this data first. After that, computer B need to decrypt it. This is encrypted, right? You cannot read it. So both machines should have information about the encryption, and there are lots of protocol and process are there between the computers on between the devices while communicating. Let's say I am teaching you in English. The reason behind why I am teaching you in English is there are a few people who don't know the Hindi. Otherwise, Hindi is my native language. So I am good with Hindi. Hindi is my preferred language, but I am teaching in English because it is a rule for me. This is a rule for me that if you want to teach everyone in the class, you have to speak English only, because everyone know English only. Yes or no?
Yes, sir.
Yes, sir.
And this is
Yes.
protocol in networking. In networking, this is a protocol that sender machine can send the data in such a way so that receiver machine can also understand. Okay. So through OSI model or after OSI model, different vendor devices can communicate with each other because both are using, same process, same method while manufacturing software and hardware. Let's say Dell is manufacturing one computer and HP is also manufacturing a computer. Apart from the communication, there are lots of things in computer, but there are one part that computer is used for communication also. So process of communication, process of connecting a device to internet will be same on Dell also and on HP also, because both have manufactured their devices according to OSI model. So the reason why we come up with OSI model is to make communication possible between different vendor devices. Now second question is, what is OSI model?
Open system interface.
What is? Yes.
Open system interface.
Open system interconnection.
Yes, sir.
Okay, this is the full form of OSI model. Can anyone tell me the logical answer of this question? What is OSI model?
This is the layered model of communication. How each layer perform the specific task.
Sir, this is
The basic model of OSI model is there is a classification of each layer in which hub
I am
switches
not
and
talking about layer, brother. Just my question is, what is OSI model?
OSI
You can
model
say
is
All the
OSI
set
model.
of rules for the communications.
Rule for communication. Okay.
Sir, this is
because in the same language we can communicate with each other.
Okay.
Sir,
Anything else?
this is the reference model to stabilize the communication between two machines. How a machine can communicate to each other.
It is in the
And
same
Very
language.
good.
Yeah.
Very good.
It cover all the aspect of network communication.
Exactly. See, I have, let's say, two computer 1, computer 2. Like when you are leaving your home for office. See, before sending any data from computer A to computer B, before sending any data, suppose computer A need to send some data to computer B. So what I am saying, before sending, computer need to perform some task. In the same way, when computer B will receive the data, computer B also need to perform some task. Like when you are leaving your home for the office, you are doing some task, like you are dressing yourself, right? You are taking breakfast. After that, after dressing, you will take your car key and then you will leave your home for the office. Yes or no? So these are small tasks that we perform before leaving our home. In the same way, before leaving the computer, any data need to perform some task. Because let's say on this computer there are some data at application layer, let's say, or at any layer on the computer. Don't discuss about the layer now. So directly I am saying data. There are some data on computer number 1. I need to send this data to computer B. How I can send the data directly? It is not possible. Suppose if you have a letter and you need to send that letter to your brother who is living in different city. So you cannot send letter directly. You have to provide the source address, destination address on the envelope. Then only you can send your data to the actual destination. Yes or no?
Yes, sir.
In the same way, if I want to send this data to computer B, here also we need to perform some task. We need to add some extra information with header, with data.
Source ID, destination ID.
And whatever extra information will be added by computer number A, that extra information should be removed by computer number B. Yes or no? Because at the end, user need only data. The rest thing we are doing only for sending this data to the exact destination. Yes or no?
Yes, sir.
Okay, so according to me, OSI model is nothing but it is a process which tells us how data will out from a computer and how data is going to enter in a computer. How data will out in a out from a computer and how data will enter in a computer. This is simple task. And can anyone tell me the logic of dividing anything, guys? Why we divide anything? Like suppose if I will give you a book of 1000 page and there is not unit wise, chapter wise, can you read that book? If there is no chapter, there is no unit, no topics, and total number of pages in book is 1000, let's say. If I will tell you to read the book, can you read? No. It will be very difficult. So we divide anything to make that thing is easy. We divide anything to make that thing easy. So that's why we divide this task, one single task, into some part, so that any new network engineer, whenever new network engineer will come in the industry, they can easily understand the concept. Getting my point? Why we divide it? We divide anything to make it easy. So that's why we divide the task, entire task, into some parts. So we divide this entire task into 7 parts. First is
Layer.
application layer. Then
Layer.
presentation layer. Then
Transport layer.
Session layer.
session layer. Then
Transport layer.
Transport layer.
transport layer. Then
network layer,
Network
network
layer.
layer. Then
physical layer,
data link layer.
Data layer.
Data link layer.
And then physical layer.
Physical layer.
Physical layer.
Guys, application layer is layer 1 or layer 7?
Layer 7, sir.
Layer 7.
It depends. We are talking about
Okay.
the
Sender or
sending
receiver, no?
Yes. If we are talking about the sending perspective, then application layer will be first layer. If I will talk about the receiving perspective, then physical layer will be the first layer. Let me make you understand with one example. Yes. Computer A, computer B. Computer A is sender and computer B is, let's say, receiver. So here OSI model will be application, presentation, session, transport, network, data link layer and physical layer. At physical layer, this device, computer A, will out the data from the link, from this link. But when computer B will receive it, it will receive at physical layer. Then OSI flow will be physical to application. Physical, then data link layer, then network layer, then transport layer, then session layer, then presentation, then application. Like this. This is your sender, this is your receiver. So on sender machine, application layer is layer 1, presentation is layer 2, session is layer 3, transport is layer 4, network is layer 5, data link layer is layer 6 and physical layer is layer 7. Here physical layer is layer 1, data link layer is layer 2, network layer is 3, transport is 4, session is 5, presentation is 6 and application is 7. Done?
Done.
Deepak, is it clear?
Yes, sir.
Great. Now, let's start from application layer. First of all, I must tell you the upper 3 layer is not for you guys. Application layer, presentation layer, session layer, and transport layer. Network, data link, and physical. So these are 7 layer. If I will talk about the upper 3 layer, means these layer are not for you. These are called upper layer. These upper layers are for software engineer. Software engineer works on these 3 layer, and your actual work will start from
Physical layer.
transport layer. As a network engineer, transport layer, network layer, data link layer, and physical layer, these 4 layers are very important. Getting my point? Getting my point, guys?
Yes, sir.
Yes, sir.
As a network engineer, you will work on the lower 4 layer. Done. Lower 4 layer means transport layer, network layer.
Network layer, data layer, physical layer.
Exactly. Okay, if I will talk about the application layer, so what is the use of application layer in OSI model?
It translates the IP into
Application
Generate the
layer,
traffic.
application layer is
Collect the data.
responsible to provide you actually user interface. User interface so that you can interact with actual software. Let's say if you want to access the web page of Google server, so you need one user interface, yes or no?
Yes.
This is what? This is user interface. Through this interface, I can interact with Google server, www.google.com. Yes or no?
Yes, sir.
So this interface, user interface, is provided by application layer. Getting my point? Application layer is simply responsible to provide you user interface, like CMD. CMD is also one user interface. Through CMD, I can ping www.google.com, or I can take telnet access. Yes or no? Telnet www.google.com 443. See, I have telnet access. So these are what? User interface. And which layer is responsible to provide user interface? Application layer. Who work on this layer? Software engineer, software tester, or software developer who design the application. Got it? Got it, guys? So it's, we can say in single line, it's provide user interface, we can say. If I will talk about the presentation layer, so what is the use of presentation here in OSI model? Can anyone say anything?
It defines types of data.
It's clear with the name. It present the data. It
Formatting of
present
data.
the data. Yes, formatting of data like encryption, decryption, compression, decompression. formatting the data, or you can say representing the data in actual format. As you know, while transmitting, while sending, computer will perform encryption, and when receiver machine will receive the data, it will perform decapsulation. Decryption. So at presentation layer, actually machines are performing encryption and decryption. So it is for encryption, decryption, compression. Compression means reducing the size. Yes or no?
Yes, sir. Yes, sir.
Compression and decompression. Like if you need to send one file whose size is, let's say, 1 GB, and WhatsApp is not allowing you to send 1 GB file to your friend. So what you can do, you can compress the data and your friend can decompress it. Decompression. After that, if I will talk about the session layer. So session layer is responsible to maintain the session. Maintain the session. Maintaining session means, see, here I have multiple tab. I have opened multiple tab. Here I am running WhatsApp. Here is Google Meet. Here let's say I am saying google.com. So Google page, and in the Google, let's say ICMP type. So see, there are multiple tab is running in a single browser. But is it possible, guys, that reply from Google Meet will open in WhatsApp tab? Or WhatsApp reply will come in this tab, in third tab? Not possible. Yes or no? If I am sending one message from WhatsApp tab to someone, and when someone will give reply, that will come in this tab only, in tab 1 only. Yes or no? Because of session layer. Session layer have record that from which tab I have sent the request to which server. So session layer is actually responsible to create the session, to maintain the session, and to terminate the session. Not only maintain, create, maintain, create, maintain, and terminate. Terminate the session. Done. Now there are lots of services available at application layer. There are lots of services available at presentation layer also and at session layer also. But the services, let's say at application layer, there are some service like HTTP. HTTP is what? HTTP is a protocol, and service is web page, right? Service is what? Remote access. So all the services of application layer can be accessed by a protocol. So we will understand the protocol of application layer. That is also for network engineer. Okay, but this is not the working of network engineer, that how application layer works and how to design the application. Okay, so we are simply going to learn the application layer protocol and the working of this layer. That is, it provides simply user interface. Done. Now the important layer is transport layer. So now who will explain what is transport layer? What is transport layer?
It is responsible for seamless delivery of data from sender to receiver.
It provides
End-to-end delivery of data.
yes, service to service communication. Like if I have two computer over here, or one computer and one server. This is computer and this one is, let's say, server. IP address of this computer is 10.1.1.1. IP address of this server is 10.1.1.2. On this server, I am running some services like HTTP, like DNS. Done. Suppose this computer want to access HTTP service of this server. Through IP address only you can send the data to this machine, right? Through IP address, what we can do, we can send the data from this computer to this computer, not to service. Like if you want to send the HTTP data from this computer to this computer, so transport layer is required, right? This is host to host communication. Through IP address 10.1 can communicate with 10.2, yes, and this is nothing but host to host communication. Means one host are able to communicate with other host. This is not service to service communication. Yes or no?
Yes, sir.
So transport layer provide service to service communication, and there are two important protocols working at transport layer, that is TCP and UDP.
Sir, can we say that it is responsible for the port-to-port delivery of message?
Yeah, you can say that also. Communication. The two important protocol work at this layer is TCP and UDP. We will understand TCP and UDP in detail, don't worry. Okay. Or we can say transport layer is responsible to provide source port and destination port to the data. Source port and destination port to the data. That also we can say. Okay. Leave. After that, network layer. So it provides host to host communication, or what we can say, it provides logical address. Logical address means your IP address. Data. Yes. Who have question? Yes, Rohit. Yes, Rohit. Do you have any question?
No question, sir. By mistake, I raised the hand. Sir.
Okay, no problem. So network layer provides logical address to data. Logical address means IP address. If I will talk about the data link layer, so data link layer is responsible to provide which type of address?
Address. Physical address.
Yes.
MAC address.
Very good. Provides MAC address to data. And what is the use of physical layer? Physical layer
Provides
convert
installation of device. Installation of devices like survey of the
converts data
Converts
into
data from
bits, and
physical selection.
bits to maybe signal or to light, right? Electrical signal, or if you are using optical fiber, then to into light wave, and after that it will transmit on the link. Yes or no? Yes. This is just an overview of OSI model. Is it clear? Anyone have any confusion, any doubt, guys? We are going to understand transport layer, network layer, data link layer, and protocol of application layer in detail. This is just an overview. So is it clear?
Yes, sir.
Okay. Before starting OSI model, let me make you familiar with one file which I have already shared with you guys. Types of communication, you already know there are 3 types of communication: unicast, multicast and broadcast in IPv4. Modes of communication: simplex, half duplex and full duplex. You guys know about it, yes or no? Or
Yes,
you can
sir.
read. Simplex is nothing but it is an one-way communication. Half
One-way
duplex is
communication.
two-way communication but not at the same instant of time. And full duplex is two-way communication at the same instant of time. Router and switch work at full duplex and hub works at half duplex. You can read here also. After that, if I will talk about the networking devices, so we have NIC card. You already know about the NIC card, hub, and we are going to understand hub, switch, router later. Collision domain and broadcast domain also. Now topic is not this one is my topic here. Memory of router, okay. OSI model. See here, application layer acts as an interface between user and actual application. This layer tells us that application is internet based or not. Definitely. Do you think if I need to send one book from one computer to another computer, let's say two computers there, both are connected through one Ethernet cable, computer A, computer B. On computer A, there is one book of CCNA. And I need to send CCNA book to computer B from computer A. Do you think that internet is required?
No.
Is internet required, guys?
No, sir.
No, sir.
No. So how this machine will came to know that when internet is required and when internet is not required? Actually, for that application
For
layer
the
is responsible.
Port number.
Application layer is responsible for that. Okay. Yes, Adil. Yes, Adil. Do you have any question? You have risen your hand. You have raised your hand. Do you have any question? No.
Sir, your application layer control the port number at transport layer.
Yes. All application layer protocol have one port number. Okay. So we are going to understand port number also. Just wait. Till now we had not discussed port number. Application layer tells that application is internet based or not. Okay. After that, there are various services like web service, like file service, like remote access service, mail service, time service, etc. These are the services of application layer. Okay. These are the services of application layer. Important services like web service, very important service. After that, file service is also important service. Remote access is also very important. Time services very important. Mail services very important. And these services are accessed with the help of some protocol like HTTP, HTTPS, TFTP, Telnet, SSH, SMTP, FTP, DNS, etc. These are the protocols of application layer. What is the use of this protocol? These protocols are used to access the services. Like if you want to use web services, so you have two protocol, HTTP
HTTPS.
and HTTPS. If you want to use file service, so again you have two protocol. One is FTP
TFTP.
and TFTP. Very good. If you want to use remote service, remote access service, you have two protocol,
Telnet.
Telnet,
and Telnet.
Telnet and SSH.
SSH. Time services.
SMTP.
Very good. Mail service.
DNS. No.
Mail
SMTP
service.
POP3.
Very
SMTP
good.
for mail service.
Very good. After that, we have dynamic host configuration, DHCP protocol to configure IP address automatically to the machine. That is also a service. Configure IP address
DHCP.
automatically to the machine. For that, we have protocol that is DHCP, like that. Okay. Done. Now, second layer, presentation layer. So at this layer, data is presented in the standard format. The data can be encrypted, the data can be decrypted, compression and decompression at this layer. Like 1, 2, 3 can be encrypted into ABC, and again ABC can be decrypted in 2, 1, 2, 3. This is nothing but encryption. Done. Then if I will talk about the session layer, so session layer, create, maintain and terminate the session. This is done with the help of session ID. It keeps data different sessions separate. Yes. And then next topic is port number. So before discussing port number, anyone know about port number, guys? Like what is port number? Why we are using port number in networking?
Port number is a 16-bit number, which is
Okay.
used to deliver the data to the port to port.
For protocol, there are different port numbers. For
Used to
Okay.
distinguish between the services.
So size of port number is
16-bit.
16 bits. So we represent port number in which format?
Decimal.
Decimal.
Decimal. (16 bits) and we represent it in decimal. So what will be the range of port number, guys?
0 to 653
0 to
1023.
65535. 65535.
35. This will be the range of port number, yes or no? Now very important thing is, what is port number? Why we are using it?
To distinguish between the services.
Sorry, can you speak again?
To distinguish between the services.
Port number is unique ID of protocol in computer networking. Through port number only we can identify the services.
Protocol services.
So what we can say, port number is an unique ID of
Of
each
the
and
protocol.
every protocol.
Okay.
Done.
Yes.
All protocols which works on application layer and transport layer. A protocol is working at layer 3. Tell me, will that protocol have port number?
Yes.
No.
No.
Layer 3 IP address.
Yeah, I played
They
that.
will have protocol number, not port number. There is one more term, that is protocol number. Protocol number is different. Port number is used to identify what? Services.
Service protocol ID.
Yes. So all application layer protocol and transport layer protocols will have port number. And all lower layer protocols, like protocols which works at network layer, that protocol will have port number.
Port number, protocol number.
Protocol number. Done. So port number is an 16 bits value represented in decimal range will be this one, and port number is an unique ID of protocol in computer networking, and you know these are the important port number. Okay, and we divide port number in two parts. First one is well-known port number and another one is unknown port number. Now question is, what do you mean by well-known port number? The port number which we already defined to protocol. Already defined to protocol, or we can say reserved. Reserved for protocol. And unknown port number are free. Which are free, which we have not assigned to any protocol. Like see, FTP. FTP is using two port number 20 and 21. This is from which range? Well-known port number, yes or no?
Yes, sir.
SSH 22. Telnet 23.
23.
SMTP
25.
25. DHCP 67 68. POP3 110. NTP 123. HTTP 80. So these all protocols are from this range, from the well-known range, yes or no?
Yes.
Here we should add HTTPS also. HTTPS port number is 443.
443.
So we have two types of port number. One is well-known and another one is unknown. Well-known are those port number which we already assigned to the protocol. And then we have concept of transport layer. Now this layer provides reliable and unreliable delivery. Reliable and unreliable delivery. After that, perform error correction before transmission. Two protocols work at this layer, that is TCP and UDP. TCP is an transmission control protocol and UDP is an user datagram protocol. TCP is a connection oriented protocol, UDP is a connection less protocol. So these are some basic difference between TCP and UDP. We are going to understand this also. Okay. Now, till session layer, hope everything is clear. Mohan, please mute yourself. Yes. Transport layer. See, whenever transport layer will receive any traffic from upper layer means from the application layer or presentation or session, right? Doesn't matter from which layer, transport layer have received the traffic. On transport layer will receive any data, right, from the upper layer. What transport layer will do? First, transport layer will decide that I will use which protocol with actual data, because at transport layer there are two protocol, TCP and UDP. So any one protocol can work for this data, and this one is a predefined thing. This one is predefined. Like if you are accessing web page, that means your protocol is what? HTTPS. And whenever transport layer will receive a traffic of HTTPS, it will use TCP. It will use TCP. So when transport layer need to use TCP and when transport layer needs to use UDP, that is predefined. While designing the software, it is predefined. Now this is secondary thing, that which type of services need to use TCP and which type of services need to use UDP. That is different thing. What I am saying, the data which transport layer will receive from the upper layer, that is predefined, that transport layer will use TCP and UDP, TCP or UDP with that data. That is predefined. If data is of HTTP, transport layer will use TCP. If data is of, can anyone tell me one services of application layer which uses UDP?
DNS.
DNS, very good, like DNS. By the way, DNS is using both TCP and UDP,
Yes,
but
sir.
generally it using TCP, UDP.
DSCPs are used only UDP.
Okay, DNS is also fine, no problem. We will understand when DNS use TCP, but mostly when your computer will generate, DNS query, that time your query will be UDP based. Okay. So first, before understanding anything else at transport layer, we need to understand the difference between TCP and UDP. And the first difference between TCP and UDP is TCP is a connection oriented protocol and UDP is a connection less protocol. What do you mean by connection oriented and connection less?
Means sir, TCP will first establish secure connection between sender and receiver. After that, he will transfer data. But UDP, in the first instance, he will transfer data with connection oriented message.
Which type of connection?
Sir,
Physical?
sorry?
Physical connection?
No, sir, logical connection.
Logical connection. Okay, how machines are going to build a logical connection?
Wireless satellite.
Guys, understand, I am talking about which type of connection. Like, here is one computer and here is one server. If directly this computer sends some data to the server, and if this machine is not getting any acknowledgement, right, getting my point?
Yes, yes.
If computer A have sent some data to server and server have not sent any acknowledgement, so this is not reliable data, yes or no?
Yes, sir.
Means this machine don't know that server have received or not. Like, I need a glass of water and my brother is in next to my room. My brother is sitting in, let's say, in next to my room, and I need a glass of water. I say, hi brother, please give me a glass of water. I am not sure that my brother is coming with a glass of water or not. Yes or no? I'm not sure. I'm not sure that my brother listen me or not. Yes or no?
Yes.
But first, if I will talk to my brother, like saying, hi brother, then he will generate reply, hello brother, then I will say, please give me a glass of water. That time I am 100% sure that my brother will come with a glass of water. Yes or no?
Yes.
Means my actual data is
Reliable.
received by my brother. Yes or no?
Yes.
In the same way, to send data between two networking devices, we have two ways. One is you can directly transmit the data, and one is before transmitting the data, you will ask to the server, hi brother, hi. Then server will also say hello, and server will give you acknowledgement also that I receive your hi, and then machine will send acknowledgement, I receive your hi. Right? This is logical connection. And after that, this machine is going to send the actual message. This is what? Connection oriented as well and reliable. Done. And connection less means machines are not going to build any connection. Directly it is going to transmit the data. Done. So TCP is a connection oriented based protocol and UDP is a connection less based protocol. Second difference is TCP is an reliable. Reliable means after receiving the data, server will generate what? Reply. Receiver machine will generate what? Reply. All TCP based services will generate reply after receiving the data. And UDP is an unreliable. Definitely, if we have acknowledgement, three-way handshake in TCP, then TCP is an slow. Yes or no? And UDP is an fast. So these three differences are very important. Is it clear? TCP is an connection oriented, reliable and slow. UDP is an connection less, unreliable and fast. Whenever you need fast communication, you will use UDP service. Whenever you need reliable communication, you will use TCP service at transport layer. Done. Like video conference, we need fast communication, so we will use what? UDP. For HTTP, we need reliable, communication, so we will use what? TCP. Getting my point?
Yes, sir.
Okay. Let's say I have one computer over here. This computer is connected with one switch, and this switch is connected with one router over here, R1. From this router, actually I want to take access of R1 from this PC, remote access. So this is also application layer service, and you told me that we have two protocols, Telnet and SSH. So let's say I am using Telnet. IP address of the router is 10.1.1.1. IP address of this machine is 10.1.1.10. Done. So on this PC, if I will type Telnet 10.1.1.1, it will send one Telnet data, yes or no, to machine. Yes or no?
Yes, sir.
But Telnet is an TCP or UDP based?
TCP.
So it will not send directly Telnet data. First it will send
Hello.
Acknowledgement.
Yes. And that hello message is nothing but SYN message.
Send message.
SYN. SYN message is nothing but the TCP header. After that, this machine will send their own SYN message, SYN and plus acknowledgement ACK. And then again this machine will send what? Acknowledgement. Like that. This is three-way handshake.
Sir, what is the jumper of UDP? This is the jumper of TCP, understand, but what is the jumper of UDP? Tell me.
In UDP, directly machine is going to send the data.
For example?
If let's say Telnet is and UDP based, right? So it is not going to build any connection with R1. Directly it is going to send the Telnet data. Okay. There is no any connection between source and destination before sending the actual data in case of UDP. In case of TCP, before sending the actual data, sender and receiver build a logical connection. And while three-way handshake, machines are going to negotiate lots of things. We will understand that later. Okay. Done. Now, okay, here first this computer will send what? One SYN message. In the SYN message there will be sequence number as well. Sequence number 1, let's say, or sequence number is 0. So in the second message, that router 1 will send to router 2. Here it will send SYN plus ACK. So sequence number in SYN message, let's say 0, and acknowledgement number will be always sequence number plus 1, that will be 1. Sequence number plus 1. And when this computer will send acknowledgement, can anyone tell me what will be the acknowledgement number? 1. Because the last sequence number, last received packet from the router is with sequence number 0. So sequence number plus 1 is acknowledgement. Sequence number plus 1. Okay. Let me show you guys practically this thing once. Here what I am going to open, let's say GNS3 or even G, I can use any tool. I am using GNS3. I have two router only. In the routing, I will use, directly EvenG. I will not use GNS3. Just I am performing a small lab. That's why I am using here GNS3. I am going to capture the link between router 1 and router 2. Then I am going to enable telnet on router number 2. Here I am going to enable telnet. Telnet. Suppose IP address of router 2 is 12.1.1.2. Guys, I will use 12 network between router 1 and router 2 always. I will use 12 network between router 1 and router 2 always. Whenever I will design any topology between router 1 and router 2, I will use only 12 network. So this is very important for the routing. Try to understand the IP configuration from now only. Okay, like between router 1 and router 3, I will use 13 network. Here IP address is 12.1 on router number 1, 12.2 on router number 2. Done. Let me configure the IP address. R1 config T interface F0/0 NoSet and IP address 12.1.1.1 0. I'm using /24 /24 here also /24. Done. App configure IP address only on router number 1, and there is one table, show TCP brief. By running this command, you can check the TCP table. So is there any information? No. Like there is no any logical connection. There is no any connection, TCP connection between router 1 and router 2. Now I am going to configure IP on router number 2. Config T interface F0/0 NoSet and IP address 12.1.1.2 255.255.255.0. Done. App configure IP address on both router. This is my telnet router, so here I am going to enable telnet. I am just going to run line VTY04. This is command to enable the telnet, and password is Cisco and say login. After that, let me configure one enable password as well. Enable password, that is also Cisco. Done. Now I am going to capture the link so that I can show you the how router 1 and router 2 is going to build logical connection. Done. See. Okay, from router number 1. Now you can verify the TCP table as well. I am going to say telnet 12.1.1.2. Done. See, it is trying and it is asking for password. Password is Cisco. Here you can see I have access of router 2, enable, and password is Cisco. And so TCP brief. You can see there is one logical connection between 12.1.1.2 and 12.1.1.1. State is stabilized. Done. Port number. Who is using port number 23? 12.1.1.2. 12.1.1.2 is telnet server and 12.1.1.1 is telnet client. So this 12.1.1.1 is using a random port number. Yes or no? This is random port number. And this one 23 is well-known port number. Who is using? Router number 2. And in the capturing, see, this is the actual telnet message. Yes or no? These are actual telnet message. Yes or no? And before this actual message, are you able to see the SYN message first? Who is sending this SYN message? I'm talking about the upper one, this SYN message. Who is sending? 12.1. Means here is R1, here is R2. First of all, R1 have sent one SYN message. SYN message. Source IP address is 12.1, destination IP address is 12.1.1.2. Source port number is random and destination port number is 23. Done. Sequence number is what? 0. Okay. See the SYN plus ACK message. Who is sending? Router 2. Router 2 is sending SYN plus ACK plus ACK. After that, source is this one, destination is this one. Source port number is 23. Definitely when router 2 will send the acknowledgement and SYN message. So that time router 2 is using which port number? 23, because this one is telnet server. And sequence number is 0 and acknowledgement number is nothing but 1. After that, again 12.1 is sending one acknowledgement only. Here you can see this one is SYN message, this one is SYN plus ACK, and this one is only ACK. Router 1 will generate one ACK message. Done, and acknowledgement number is 1. After that, you can see the actual telnet message. Who is sending? 12.1 to 12.2. Done, guys. So whenever transport layer will receive any traffic and which that traffic is TCP based, then transport layer will build one logical connection first. One logical connection, and that can be verified by running command show TCP brief. Let me terminate.
Sir, here sender is initiating the traffic in a random port. How receiver will know it is the TCP connection?
Sorry, can you speak again, brother?
Sir, here sender is sending data in a random port. 60 something you have shown.
No, source port number is random. See, at here or at application layer, router 1 will generate one telnet traffic, yes or no?
Yes.
Telnet. And destination port for telnet will be, what is the defined port number for telnet?
23.
23. So transport layer have already information. This is predefined in the software that for the telnet you will use which service? TCP, and destination port will be 23. So telnet and transport layer is going to add what? Source port and destination port. So source port number will be random port number, let's say G1025, and destination port will be 23. This is the actual traffic of telnet, right? But first machine will send what? SYN message. So in SYN message, source port will be what? Random port number, and destination port will be also what? 23. So actually transport layer will copy source port and destination port from here. And when R2 will receive it, R2 will generate SYN plus ACK. SYN plus ACK. So it is giving acknowledgement. So it will give acknowledgement to whom? From where it is receiving the traffic, from this port number 1025. So destination port will be this one. Done? Done, brother?
So means the sender will initiate the traffic in a random port number.
Source port number will be the random port number.
Sir, why?
Destination is
Why
predefined.
if it
You
is
know.
using telnet service, it can have used 20 port number 23, sir.
No. See, what is the port number of HTTPS? HTTPS port number is 443.
443. Okay.
If I will type in my browser www.google.com, so source port number will be the random port, destination port will be 443. Yes or no?
Yes.
From your computer, if you will also type www.google.com, source port number will be different, but destination port will be always what? 443. Doesn't matter from where you are sending the traffic to Google server, to HTTPS. Destination port will be always 443. And source is random. Source is independent. Source can be anything.
Okay.
Right. From UC browser, maybe source will be different. From the Google Chrome, source will be different. Destination will be always same. If I am sending the telnet traffic, so destination will be always 23. Done?
Okay, sir.
Let's say same router, you are also trying to access R2 from your computer. So source port number will be different, but destination will be 23. So there will be two TCP connection. Let's say here I have one more router, R3. And let's say this router is using port number what? 1025. And this one is using 1026. So router 2 have two logical connection. One with router 1 and one with router 2. Here with both router 1 and router 3, port number that router 2 will use is 23. Here also, and port number that router 3 is using is random. Yes or no? And same thing you are able to see here also. So TCP brief. Now there is no connection because I have terminated the telnet connection. So let me say telnet again. Cisco. So
सर
yes.
सर इसमें आपने क्या मतलब समझाया, थोड़ा समझ में नहीं आया सर। जो आपने
कौन सा?
जो आप कमांड पोर्ट में CMD में समझा रहे सर, तो सर ये क्या समझाया, थोड़ा समझ में नहीं आया सर, थोड़ा शॉर्ट वे में समझा देंगे सर।
कौन सा नहीं समझा आपको? CMD में क्या समझा रहा हूं मैं?
TCP के वो जो आप जो सर TCP जो कमांड करते हैं,
have you got it that TCP based services build logical connection first?
Okay. Yes, sir.
And UDP based services send traffic directly.
Okay. Yes,
so
sir.
there is no any acknowledgement. The same thing I am explaining over here. On router number 2, I have enabled one service which is using TCP.
Okay.
Right? After that, I use that service from router number 1. And here you are able to see there is one logical connection. I'm talking about this logical connection only.
Okay.
That's it. Done. So here you can see this is port number of 12.1.1.2 is 23 because I am running telnet service on router number 2. There is one connection between 12.1 and 12.2. And a state of this connection is stabilized. Fine. Until and unless I will not terminate this telnet connection. See, once I will terminate the connection, so TCP brief. The logical connection is also terminated. Now this router is free. Done, guys. Done.
सर
और
एक्चुअल डेटा जब ट्रांसमिट होता है उसका सीक्वेंस और एक्नॉलेजमेंट नंबर दिखा सकते हैं कैसे कैलकुलेट होता है
वो अलग होता है
उसके बारे में थोड़ा बता
सीक्वेंस नंबर ओके
थोड़ा सा बता दें
while three-way handshake sequence number and acknowledgement will be like this. First this router will send SYN message on sequence number 0, right? So router 2 will send acknowledgement on acknowledgement number 1 because sequence number +1, and it will send there on SYN message with sequence number 0. So when router 2 will generate acknowledgement, it will give acknowledgement on acknowledgement number 1. But while transmitting the data, let's say router 1 is transmitting now actual data, right? Here sequence number is, let's say sequence number is 0, right? So this time router 2 will give acknowledgement on node acknowledgement number 1. This time acknowledgement will be data size plus sequence number. So let's say size of data is 100 byte. So acknowledgement number will be what? 100. It will give acknowledgement on acknowledgement number 1. Done?
Done, sir.
Okay, let's say this router need to send some data whose length is 100 byte, here 100 byte and 100 byte. Right? First data, when router will send first data, it will send sequence number what? 0. So it will give acknowledgement on acknowledgement number 100. In sequence number, in second data, it will send sequence number what? 1, let's say. So it will give acknowledgement on what number? 101. Getting my point? Hello. Size of data plus sequence number. Sequence number is what? 1, and size of data is 100. Like that acknowledgement will work. Okay. Here are you able to see the telnet traffic?
Yes, sir.
See, who is sending this first telnet traffic? 12.1.1.2 to 12.1.1.1. Let me open it. What is sequence number? Sequence number is what?
1.
1. And acknowledgement number is?
13.
13. Here see, router 1 is sending this data. Here sequence number is 13 and acknowledgement number is 67. Here what we can do here, how we can check the size of data. We are not able to see the size of data. Otherwise, later on I will show you this thing. Don't worry.
Okay,
In
sir.
TCP header, we will understand the acknowledgement and sequence number as well. Sequencing and acknowledgement.
Sir,
later.
the packet sync plus hack, these are the contain random kind of a data, sir. When we send the sync and receive the sync plus acknowledgement while TCP handshake.
Well, three-way handshake.
Three-way handshake, sir. So these packets
So
contain random data, sir.
Not random data, only random source port number.
Okay.
There is nothing. This is TCP header actually. SYN message is TCP header. Are you able to see any other information except TCP header? No.
Okay, sir. I got it. Source port, destination port number,
Yes.
sequence, and okay.
This is just a header, TCP header. Okay. You will understand TCP header, then you will came to know that okay, SYN message was that. Okay. Done. Now transport layer. So it provides reliable and unreliable delivery perform. Okay. Here is difference between TCP and UDP. So TCP is a connection oriented protocol and UDP is a connection less protocol. Now we don't have sequencing as well in UDP. We don't have sequencing. We don't have any sequence number. Let's say here I have computer, here I have computer. The services between this computer is UDP, and from here I am sending three data packet. Okay. So while using UDP, we don't have sequencing. I have sent data 1, data 2 and data 3. Let's say computer 2 have received 2 number of data, but it have not received the last one. So sender machine need to retransmit all data again. Because there is no sequencing. This machine don't know that which data I have received, which data I have not received. Yes or no? It means we cannot arrange the receiving data in the sequence. Yes or no? It is not possible to arrange. Let's say here if I have done sequencing like sequence number 1, sequence number 2, sequence number 3. Now receiver machine can definitely arrange the receiving data, and if receiver machine have not received this data, so it can ask for the data whose sequence number is 2. Yes or no? So this machine can retransmit only a single data again. But in case of UDP, it is not possible. So this is also one difference. Right? We can arrange receiving traffic in sequence, but we cannot arrange receiving traffic in sequence in case of UDP. Data retransmission is possible, but data retransmission is not possible in UDP. You have to retransmit the entire data. Okay. TCP is an reliable protocol. You already know this. UDP is an unreliable. We can achieve flow control as well in TCP, but we cannot achieve flow control in case of UDP. Windowing is used in TCP and windowing is not used in UDP. Now our topic is
what is flow control? Flow control, sir. Can you explain?
Flow control we are going to discuss in upcoming day.
Okay.
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 Flow control means, brother, like, see, whenever a computer or any networking device receive any data, first of all, networking device hold that data in buffer memory. In which memory? In buffer memory. Before executing, before the process. First, it will hold it in buffer memory, and after that, it is going to execute the data. It is going to process the data. Let's say a device have full their buffer memory because they have received lots of data, and still someone is sending data to that machine. That is overflow. Yes or no?
Yes, sir.
Right? So we cannot control the flow of traffic in case of UDP, but we can control this flow in case of TCP. Done.
Does it mean that UDP will discard the data?
Yeah, definitely. It will discard the data. It will drop the data. See, I am speaking, I am teaching you because of internet. Let's say you have not received some of my voice. Do you think that my computer will retransmit that?
No, sir.
Right? It will drop that. But if I am using TCP services, definitely my computer will retransmit that. Because in case of TCP, there is acknowledgement. If machine have not received acknowledgement, and if receiver machine have given the acknowledgement, that means definitely their buffer memory is available. While three-way handshake, it is going to negotiate their buffer memory as well. According to that buffer memory only, router will transmit, devices is going to decide that what should be the size of data. What should be the size of data? Because in TCP, it is not going to transmit data blindly. It is going to check like size of data should be how much data my receiver machine can handle at a time, what is the size of buffer memory of receiver machine. These things is negotiated while three-way handshake, and these are the benefit which devices is going to use while sending the actual data. Done.
Done, sir.
Now question is, what is windowing? Windowing. Let's say, brother, I have one computer over here and one server over here. On this server, let's say there are some information, some books, anything you can consider. Done. Or let's say this PC, computer and server. This PC need to send some data to server. Okay. And size of data is 1000 byte. But problem is this interface can send only 100 byte data at a time. This interface means MTU of this interface is, MTU means maximum transfer unit. The maximum transfer unit of this interface is what? 100. That means it can transmit up to 100 byte data at a time from this interface. Means this computer need to break this data into 10 part. Yes or no?
Right, sir.
Right? Let's say this is part 1, this is part 2, this is part 3, part 4, part 5, 6, 7, 8, 9 and 10. After that, computer will send first packet to the server first. Then server will give what? Acknowledgement? Definitely. Yes or no?
Yes, sir.
Acknowledgement. After that, computer will send what? Another packet, packet number 2. Again server will give what? Acknowledgement. Yes or no? Then it will send third packet. Then again server will give what? Acknowledgement. Yes or no? Like this, after 10 packets, server will generate how many number of acknowledgement? 10. Guys, like this communication will be very slow, yes or no? If server will give acknowledgement after every packet, then communication between computer and server will be very slow, yes or no? Are you agree with this or not?
Yes, sir.
Yes, sir.
So to reduce the number of acknowledgement, we come up with a technique called windowing. So windowing is nothing but a technique which is used to reduce the number of acknowledgement. See, with the help of while three-way handshake, if both machine is going to decide one window size according to their buffer memory. First, server will tell to computer that I can store 500 byte in my buffer memory. I can store 500 byte in my buffer memory. Size of buffer memory of server is 500 byte. Done. Server is saying that I can store 500 byte data in my buffer memory. So computer will say to server, okay brother, if you can store 500 byte data in your buffer memory, so do one thing. First I will send you 500 byte data, then you will process that data, you will give one acknowledgement to me, and after that I will send you the next data. Getting my point?
Yes, sir.
Means now window size is now 500. That means after receiving the 500 byte of data, server will generate acknowledgement. So now acknowledgement will be like this. First, computer will send how many packet? 1, 2, 3, 4, 5. Then server will generate one acknowledgement. After that again it will send how many data?
5.
How many packet? 5.
5.
And then again server will send what? One acknowledgement. This is the concept of windowing. And on each packet there are sequence number, yes or no? There are sequence number 1, 2, 3, 4, 5. Total size of data is 500. 500, yes or no? And here also total size of data is 500.
Right.
So it have sent total 1000 byte data, and it have received only 2 number of acknowledgement with the help of windowing. So windowing
Sir, does
is,
it mean that fast technology from server will be 5001 or 101?
sorry,
The acknowledgement from server will be 501 or 101?
501. Here acknowledgement will be 501, and here acknowledgement will be what?
1001.
1001. Okay. So this is concept of windowing. Done. Let me move. So windowing is used in TCP and windowing is not used in UDP. And how UDP can use windowing, that is also not possible, because in UDP sender machine don't have any knowledge about the buffer memory of receiver machine. After that, 4-way handshake done in TCP and 4-way handshake not done in UDP. Okay. TCP is a slow process, UDP is a fast process. Okay. Default.
Sir, you told 3-way handshake, right?
3-way handshake is used to. What is the use of 3-way handshake? It is used to
establish a connection.
Yes. And 4-way handshake is used to terminate the connection.
Got it.
Okay. There is one more message, that is fin message. Finish. Okay. TCP is an okay. Default size of TCP header is 20 byte. 20 byte, and default size of UDP header is 8 byte. So we have discussed two advantages of UDP as well. First is see size of UDP header means UDP will add only 8 byte extra information, but TCP will add how many bytes extra information? 20 byte. Second benefit of UDP is fast and TCP is slow. Now we have some services protocol like HTTP, HTTPS, Telnet, SSH, etc. are the protocol which works at layer 4. Guys, as a network engineer, you have to remember all important protocols of application layer uses what port number and what services at transport layer. Like here also you can see like FTP uses TCP and port number 2021. SSH uses port number 22 and it uses which services at transport layer? TCP and UDP. Telnet is uses which service at transport layer? TCP. Like this. DHCP is using UDP. Okay. So as a network engineer, you should remember at least 20 protocol with port number and the services at transport layer. Done. After that, segmentation can be done in TCP and segmentation cannot be done in UDP. Okay. Here we have segmentation. We will understand what is segmentation as well. Okay. So today we have discussed transport layer. I think there are now some practical of transport layer and flow control. You can read this PDF. Windowing is also there. And tomorrow our main topic will be network layer and header. Okay. Network layer and header.
Okay.
So if anyone